Hello, this is Dr. San Abdullah with the course Deep Reinforcement Learning, and we are covering the first topic, which is introduction. And we are doing the medium level difficulty of the introductory topic, so which is lecture number 1B. And as before, we are using the personalized learning management system, easymcq.com/GoGet. This is the learning management system, and it has many wonderful features. And you can access this learning management system by using the URL in the green, and you can view the videos about this learning management system for the maximum utility by following the URL given in the blue. Now, there are 6 videos which explain the features of this learning management system, and those features have been developed by input from students like you, users like you. So it allows very powerful full text search, advanced and basic search throughout the content of this course and other courses which are available here. And any students which have any visual disability, they can change the interface as per the font, the size, the color, the line spacing, and so on. And the text and the contents are optimized. They have diagrams, they have a hierarchy, and you can track your progress so that you know which subject you covered, which topic within that subject, and which question and answers which you covered. And of course, you can assess your performance, your learning, your knowledge accumulation by using the online testing system, which provides the details and your highlights, your weaknesses also. So the approach in this course and in other courses available at easymcq.com is a combination of the Q&A approach and the traditional slides based approach. So the slides based approach is not interactive, and it is not thought provoking, it is not very engaging. So those features are included, and the traditional approach has details which are included in this approach. So basically what we do is a blending or a blended learning approach for your benefit. So what topics are covered in this course? This is the list of topics, and we are at the first topic, which is introduction. So which consists of 15 questions and answers. Now these questions and answers are basically concepts, but since we are following a Q&A based approach, therefore these questions and answers are basically the topics. We are covering the second set of Q&A or the concepts, which is 1B, and of course this covers the medium difficulty level. And in the third or 1C, we will cover slightly more difficult concepts. So now we move on to the detailed Q&A for this video. Thank you. Learning introduction or general overview. So we start with the first concept. And what is the CPU or central processing unit versus GPU architecture? What the differences are? GPU, the graphical processing unit or graphic processing unit, which is basically the platform on which deep learning is happening. All right. So these are the key points: the core count, the number of cores in a CPU versus a GPU, which type of instructions are handled in a CPU versus a GPU, the memory hierarchy, how the memory is accessed, and how much parallelism is there in a CPU versus a GPU, and of course the use cases. The use cases are entirely different. So what I'll do is that I'll show you the diagram. Of course, the details are given, all the details are given over here. So the core count and the instruction handling. So what I'll do is I'll show the diagram, and then I'll do a basic discussion on the diagram, and then we can go back to the bullets which are left. All right. So we have this over here is the central. This is the central processing unit architecture, basic architecture, and that is the basic architecture of a GPU. So as you can see that the orange color is the control units, and the arithmetic and logical units are in green color, and the memory, the cache memory, and the dynamic RAM are in kind of a orange color. This can be a mustard color. So, but you get the picture. So, the differences which we can see is that there are fewer CPUs. Okay, CPUs has these ALUs. They are fewer in number, performance cores, and they are optimized for sequential and general purpose computing, because this architecture was developed when AI was not mainstream. As a matter of fact, I took, as I mentioned before, I took the AI course in my studies, and then people never knew about AI. But of course, I was very interested. In contrast, GPUs feature hundreds or maybe thousands of smaller, simpler cores. Okay, and these simpler cores are designed for many parallel operations. And of course, when the operations are parallel, they are simultaneous, and they are idle. I'm sorry, they are ideal for tasks requiring massive data processing, because this happens in parallel, number one, and then they are in hundreds and thousands, so they can do a lot. Of course, they have some their limitations also. Now CPUs, this CPU, okay, that can handle complex instructions, diverse instructions, and they can support advanced control logic, okay, which we all have experienced from our undergrad programs, and some of you will go through the grad programs, or maybe at your job also. So therefore they are suitable for different types and very different types of workloads. As opposed to GPUs, they have simpler instructions. Their strength is parallel processing, multiple threads, okay? And of course, they are using multiple threads because of these processors, and using a uniform execution model, right? Right. So, uniform execution model, so which limits the flexibility, of course, but it enhances the efficiency for uniform tasks. So diversity in instructions and coding is lacking in a GPU, which is complemented by strong parallelism. Okay. So repetitive tasks. Then is the memory hierarchy. CPUs use the cache hierarchy of low latency. This is very fast and flexible memory access, and they are good at handling irregular memory patterns because of a big control structure and fewer ALUs. Okay, so and of course but GPUs are designed for high memory bandwidth, because there are hundreds and thousands of these CPUs, and therefore they favor consistent memory operations, not lot of diversity and parallel threads for performance. So they are made for high performance parallel computing. Okay, these GPUs. So you can imagine when you have a GPU with hundreds and thousands of these ALUs, and if you have thousands of GPUs, you have a millions of ALUs. So you can see that the performance boost this architecture can provide. So CPUs, of course, they can do parallelism also, but that is limited. Few complex threads. But GPUs are designed, they are prioritized for data parallelism, okay? And that is performed on across thousands of data points. So this makes GPUs highly efficient for matrix. This is a matrix basic matrix operations and large scale computations like deep learning and graphical rendering. So you can put them together and you can have the entire screen. Every pixel could be represented by an ALU. So you can imagine that how quick and how fast rendering of the screen would be there. And finally, CPUs are I'm talking about the use case. So we are here, use case, okay. So as we go use case, CPUs are versatile and they are good for general purpose computing, okay, like application execution and logic heavy operations. But as opposed to CPUs, GPUs specialize in computational intensive tasks, parallel workloads such as deep learning, simultaneous, okay, or parallel processing for images, simulations, okay, and of course they complement the CPUs in high performance systems. So they are different animals in a nutshell. All right, so we can close this. Okay, this drop down. And so what is a GPU based deep learning framework? Okay, so what is that framework? So let's take a look at it. So we have GPU powered training, right? We have GPU powered training, and what is GPU powered training? I can discuss this GPU powered training basically, because this uses the massive parallel processing power of GPUs, and it accelerates the training of the neural networks, which we have discussed very briefly. And then they have, let me first show you the diagram, okay? So what I'll do, so these are the details are here, all the details are here. So let's look at this diagram, okay? So what we have, of course, this for training, we have a large we have a large data set, okay? And this has multiple layers, right? So I've only shown very few layers here, okay? So we have this feed forward and feed backward, which we will discuss. Entire topics, okay? So this power of the GPUs basically that reduces the training time significantly, and that allows to work with large data sets as over here, right? So so we have it. So if it is not a dog, then we're looking for basically trying to recognize what a dog is, or what are the characteristics of a dog, okay? And then of course if there's an error, okay, and versus the labels which were of a human face, okay, some description is given over here. So that's the GPU power training. Then is the optimized computation. If I recall correctly, I think it was, yeah, it is optimized computation. So what is optimized computation? These frameworks, okay, they use libraries which we will discuss, okay, and perform mathematical operations such as matrix multiplications and convolutions, and that is done very efficiently. So I've mentioned you that if you had taken a course in computer graphics, that involves a lot of matrix operations. I took that course as a grad student. So these multiplication matrix multiplications lead to faster execution and better resource utilization during training and inference. Now what is happening is that the GPUs, which were developed for fast and quick gamification, or to running the games, right? So the processing power and architecture was there, which supported deep learning. That's it. That's the key over here. And then is the high parallelism that we've already discussed, right? So high parallelism, there's GPU support thousands of simultaneous threads. Okay. And we have frameworks that harness, okay, this batches of data or layers of model concurrently, and which we have seen, which is crucial for training deep neural networks. Why? Because they have large scale computations and they have iterative updates, right? So that architecture, as a matter of fact, supports it. So let me go back again to that architecture. And what I was trying to explain was, so for the training we have this large data set, okay, and then basically we are trying to infer, right? So then we are trying to infer that based upon this training, right? Then we would like to identify that which of the pictures was that of a human face. So we have this smaller varied data set, okay, and based upon that error message, this deep learning network has been trained, and then with the feed forward, we are able to identify the human face, okay. So this is the model which we are talking about. So we have so these deep learning networks, model abstraction, which I probably mentioned before, they provide high level interfaces for doing what? For defining and training models without needing to maybe code low level GPU work. Okay, that's not done. So we have automatic differentiation. Okay, And we have, and how it is achieved, that is achieved through many layers, modular layers, right? And then of course it makes it more, it makes it faster. Okay. All right, so let's move on. So now the next obvious question is why there are so many GPU based deep learning frameworks. Okay, if you're not aware, there are quite a few of them. So why there are so many deep learning frameworks? I'll there's some diagram pictures here also, so you can see these some of the ones which are available in the market. So why there are so many? Because performance needs, performance needs. Uh, it's like the cars. Why there are different types of cars, motor vehicles? Performance needs. You need a vehicle uh, to like a truck for a different purpose. You need energy efficient vehicle for a different purpose. You need an SUV for a different purpose. You need a sedan for a different purpose. You need a sports car for a different purpose. You need, and so on the list goes. You need an electric vehicle for a different purpose. You need a hybrid vehicle for a different purpose. So different frameworks optimize GPU usage in a unique way, right? And to meet the different demands, okay, such what are different demands? Training speed, more efficiency, scalability, okay, and then there is the diversity in the hardware and in the architecture and the deployment requirements, okay, and of course that require different types of specialized performance, different solutions, right? And of course then performance needs are therefore different. Okay, research variety. Now, because of the fast-paced nature of AI research, okay, and like very frequently we there are news reports of different inventions or applications or uses. So that demands frameworks that support that kind of experimentation. And of course, the architecture are going to be different, novel architectures and novel algorithms. So if there are multiple frameworks that allow the researchers and the users to make a choice to among the tools which meet their requirements, okay, such as for example dynamic versus static computation of graphs, right? Or maybe comparing the sign language with some other type of language and so on. And then last but not the least is the developer flexibility. What is developer flexibility? uh, you may have a liking or a dislike for a certain language, although AI has changed this a lot. But developers have a different preference for language support and for API and for integration tools. So when there are a variety of frameworks that ensures flexibility in building, flexibility in coding, flexibility in testing, flexibility in deploying the models where across applications. And those applications you could be deploying on cloud services to edge devices, okay, and you could be catering to the requirements of the beginners or to the experts and so on. So that's why there are different frameworks around, many frameworks. All right, so let's move on. So what is NVIDIA Deep Learning SDK with respect to digits and GIE? So this is very specific to NVIDIA, which is obviously the leader in this domain. So what is the digits interface? It provides a user-friendly interface, okay, and of course that is a web-based interface. And what it does, it is for training deep learning models. So unfortunately it's not part of this course. So maybe in future executions I may offer it. So what it does, it allows the users to design networks. Okay, it allows the users to visualize the training, the progress in the training. Okay, and it also allows to manage large data sets without actually coding. So what's the benefit? Of course the benefit is that with digits you can do rapid experimentation using the NVIDIA GPUs. Okay, NVIDIA of course is the leader, And then is the GPU inference engine, okay, GIE, which is also called as the tensor, I believe it's called as tensor RT. So that's a high performance inference engine by NVIDIA. If you want to know about what is an inference engine, you just need to click on this top, go to the click on the yellow button, search, and then go to the main page and type inference engine. So what it does is that it optimizes the models which have been trained, okay, and for deployment. So what it does is getting technical. It applies. Let me show you the picture, the diagram. Okay. So this is the digits. Okay. Develop with digits. So we have this data management, and then we do the training. Okay. And then you assess the model assessment also. And then you have this trained network, which is the model. Okay. And then it optimizes this model. Okay, and accelerates. As a matter of fact, the inference, the performance of inference on NVIDIA GPUs is accelerated. So what is that acceleration? Basically, this acceleration basically leverages or makes use of the NVIDIA GPUs for faster computation. Okay, and this digits basically, this digits is basically accelerates that computation and makes efficient use of the GPUs. Okay, and then of course you deploy the deployment with GIE. This could be in embedded systems, it could be data center, it could be uh, self-driven vehicles, and so on. So these are the applications. All right. And one thing which is about GIE is that it is the inference is very fast. Okay, why? Because and it has low latency, right? Processing time is less, and therefore it is good for applications, right, where where time is at premium, like video analytics, like robotics, like autonomous vehicles, because especially for autonomous vehicles, fast decision making is critical. Okay, somebody is crossing the road, there's a turn, a car turns, a stop signal or whatever, right? So these things need to be taken into consideration. So before we end this lecture, so what is Keras and its key features? So what is Keras? So it's a high level neural network API written in Python. Okay, so let's talk more about it, about Keras. Okay, so what Keras has a user friendly interface. All right, it has a user friendly interface, and which is clean and intuitive, and it is good for beginners, and it helps in creating neural networks, and it emphasizes simplicity with minimal coding. All right, so the benefit is rapid prototyping. It is good in the education domain for experimentation. Okay, and all of this is achieved without sacrificing power and without sacrificing flexibility. Okay, then there is sequential APIs. So let me show you the diagram for Keras also. Okay, so what I'll do is that we can go over by looking at this diagram. So this sequential API, basically this allows for easy model building. Okay, so you can have a stacking of the layers one after the other, and of course that results in a simple architecture. Okay, there is single input and output, and of course for quick development and learning. So that helps for at the beginner level, right? Then you have the functional APIs. So what they do is they support more complex architectures, such as multiple inputs, such as multiple outputs, and non-linear models, because life is non-linear, and it allows flexibility. All right, and it is good for advanced use cases. Okay, so this is simpler, this is advanced, this is linear, this is non-linear, and this is single output, this is multiple output. All right, and then is the model subclassing. So what is model subclassing? So this allows custom models by Python class inheritance, right? So we'll try to do this, some of it in this course also. So what the users do is they define the layers and the forward pass, but that is done manually, and that enables dynamism in the architecture and advanced control. Okay, so and of course then is other features which make it very useful. Okay, and so that's about it for this lecture 1B of deep and reinforcement learning intro and general overview.